Hello and welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You'll now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I'm joined by Professor Mary Helen Armour, and we are both affiliated with the Department of Physics and Astronomy here at York University. Tonight we're broadcasting live from the Allan Carswell Observatory at the Keele campus in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time at York U Observatory. We also run in concert with our online public viewing, or as we call it, the OPV feed, run by the observatory staff, where tonight we will be looking at archival images because unfortunately, clouds are just rolling in and the domes are going to be closed. We also will answer your questions on YouTube live on that chat. To navigate to our show or to find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, please send us an email at observe@yorku.ca. And you can also connect with us on Instagram with the handle at YorkU Observatory or on Facebook at Allan I Carswell Ob. All of our programs are free, but if you'd like to make a donation, and we would certainly appreciate that, please visit our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. How are you this evening, Professor? Have you had any observing in over the last nice couple of days?
I was trying to look for Lyrids and not having much luck. They
for Lyra?
Lyrids.
Okay.
Meteor shower. It peaked over the last couple of days, but I didn't have much luck. I am up often early in the morning before the sun rises, and I was trying to see if I could find anything, but no joy. Even though
you must be getting up really early because the sun's up early now.
Well, I'm usually up somewhere around 5 a.m. So
okay,
I have exactly the wrong natural schedule for an astronomer because unfortunately I'm an early riser. So it's great for early morning stars. And I've been trying to catch the Lyrids. They're not a great shower, but at their peak you do get about 10 to 20 an hour, so they're worth trying to find. They tend to hit the sky around Vega, so they're not that hard to locate since Vega is so bright. But I didn't really have any luck.
Well, it's interesting because, of course, right now, the 5 in the morning moon is well hidden. So that would actually help. And you're quite rural compared to where I am. So that also makes a big difference. It's interesting. The last couple of nights in the last week we've had some clear nights, and I've had a couple of telescopes working. Well, technically, I guess astrographs, because you don't look through them, but you can take pictures with them. And I've been having two of them working overtime. I'm trying to get a Messier marathon done, not in a single night, because that's really difficult. And I'll explain what a Messier marathon for our listeners is in a second, because it is galaxy season, or which is my favorite time of the year. And because the weather's getting better, the nights are shorter, but you're getting more clear nights. And this time of year, just the way we're positioned, in our solar system, looking out at the galaxy and the universe around us, you start to see a whole bunch of galaxies visible, and they're visible from right after sunset to dawn. And it's not just galaxies in the Messier catalog. You've got galaxies. I mean, Messier had no idea what he was looking at. He was basically trying to identify comets so that he wouldn't. So he was looking for objects that looked vaguely comet-like, so he wouldn't confuse them with comets. And he often will. You've often got globular clusters which are inside our galaxy. And probably the best example of that is visible in the late night, early morning right now, which is M13. It's certainly not the biggest globular cluster, but it's quite beautiful, and it is exactly what it sounds like. It's a ball of stars, a globe of stars, tightly packed, and it's inside our galaxy. The biggest is Omega Centauri, which I was fortunate enough to image earlier this year, but you have to go to the southern hemisphere for that. Nothing exotic. I was in the Caribbean, but I was able to get an image of that, and it's lovely, and it's much bigger. But so you can go and you can look at all these objects, and they're all telescope visible or binocular visible, and a few of them are naked eye visible. Like M13, you can actually see it with your naked eye, barely under ideal conditions. So it's a great time to look around at night. And also, right now we've got Venus. Just before we broadcast, I'm in my study at home, and I drew the curtains. To keep the street lights out, so I could see a little better when I was staring at my screen. But I could see Venus as the clouds were coming in. I could see Venus on the western horizon. Really very distinctive. You can't miss Venus. It's so bright. And then a little above that right now is Jupiter, which is definitely fading a bit from opposition in January, but it's still, if you're looking for a bright object in the night sky, Jupiter's one of them. Naturally occurring objects, you've got the sun is the brightest, then you've got the moon, then you've got Venus, and then you got Jupiter. And it's interesting, Venus is bright because it reflects so much sunlight, and it's almost a white cloud. And it's about the same size as Earth, and it's relatively close. Jupiter is really very far away, but it's also mostly kind of whitish clouds. I mean, it's got bands in various colors, but its albedo is quite high, and it's very big. So it also is quite bright. People are always. I always joke about the worst thing to show people in the night sky, and it'll be coming in a couple of weeks, is Mars, and everyone talks about how Mars is kind of red, and yes, it's kind of a dull or kind of an orangish star, and if you look at it through a telescope, not that impressive. Jupiter's impressive. Venus, again, not that impressive, but Venus has phases like the moon, which is kind of cool. And these are things that you can experience right now. And, I do encourage people, as the weather's getting nice, to get out there and look up. And if you see something you don't know what it is, I mean, you can probably figure it out from the web, but send us a question. We'd be happy to answer it. Do you have something that you particularly like looking at other than meteor showers? Professor?
Well, that meteors and asteroids are kind of more my fascination. But after that, I tend to like planetary observations. Although I find some objects, M13 is always fascinated because, of course, that's where they directed the Arecibo message to years and years ago when they were sending out an attempt to communicate with extraterrestrials. Now, choosing that globular cluster, I mean, there were reasons they did it. Whether some of those stars may be too old to host life, or there are other issues with that. But whenever I hear M13, I always think of the Arecibo mission that they sent, the message that they sent out from the radio telescope so many years ago. So
yeah, it was sent from Arecibo, and it if they're waiting, if we're going to get a response, it's going to take a while because it is it's a little difficult, and it is more than one star, so it's a globe, so it's generally estimated to be between 22,000 and 25,000 light years away. So it's going to be a while before it gets there, and if someone hears it, will respond.
Yeah, it was a strange choice of target when you think about how far away it was.
Yeah.
It's like, why?
Yeah, you'd think
I know the stars are concentrated, but why so far away? It's just, I don't understand quite the thinking behind some of that, but I think it was just a test of concept that you could actually fire that kind of message out. I don't think there was, obviously, by the time you'd receive a response, who knows where human civilization is by that point, if you get one. So
that was kind of Frank Drake's big thing, launching SETI and getting into that. And of course, Drake is famous for his Drake's equation. I keep threatening to get Drake's equation tattooed on my back, and my wife keeps threatening to kill me if I do. So, but anyway, let's move on to This Week in Astronomy. Mary Helen, you've got the first item, so why don't you tell us?
I mean, it kind of, I think, leads in well from what we were just chatting about like telescope observing and stuff, because we think about telescopes of being based here on Earth. But of course, one of the things, both in science fiction a lot and in science as well, is the idea of putting a telescope on the moon, because of course you don't have an atmosphere, you don't have weather. You do probably have Earth and the sun still, up a lot of the time, which would, still have the same effect as the sun on Earth, but without an atmosphere and stuff, it would make observing so much better, because you've got that whole element gone. And especially if you're at sort of in the full moon, if you put it on like the backside, you'd have these great times when you're never pointing towards Earth, and you have such a wonderful sky to observe. And so when they sent the one Apollo mission, they did actually send a small telescope with it. So with Apollo 16, over 50 years ago, they actually put a small telescope on the moon. John Young and Charles Duke did take a small telescope and set it up. And so there is actually a telescope on the moon. But the idea of a lunar telescope has been out there for so long, because if you put it on the far side of the moon, your seeing would be so much better than anything you can do on Earth. It also, like the seeing would also be amazing, even compared to something like a Hubble and stuff, because you're still way far away from any kind of Earth glare. So the potential there is enormous, especially as Earth's skies get busier and busier with all kinds of satellites and Starlinks and all these ones that have gone up, and all the junk we have in orbit and all the light pollution we have. So, like more and more, if we ever build a lunar base, there's this sort of real thinking about what kind of telescopes could we put on the far side. And this could apply to radio telescopes as well. And in some ways, they're kind of an interesting concept, because it's like I said, you don't have to worry about weather. You don't have to worry about an atmosphere. So it makes basically like, let's pick a decent location. You don't have to go to all these sort of remote locations on Earth, like the top of mountains, whether in Hawaii, whether in Chile, whether, or try to launch them into orbit to see quite so well. So the lunar telescope idea has been out there a long time. They did take one along with them. I think it was as much a, I don't want to call it publicity stunt, but an educational thing as much as a scientific thing. But this idea has always been out there in the astronomy community. Like, if we could ever build one on the moon, it would be amazing. Because the other element is on Earth, we're limited to radio and visible. If you're on the moon, there's no atmosphere. So you could observe the whole spectrum, right? Which is the other sort of advantage. You could have like all these other telescopes that aren't really feasible on Earth, because the atmosphere blocks so much of it. So I don't know and it's like I said, all these like science fiction works always talk about telescopes on the far side of the moon, telescopes on the far side of the moon, whether it was Heinlein, whether it was Clark, whether Arthur C. Clarke, whether it was, any of these guys. This thing keeps popping up over and over again.
So yeah, it's interesting. The Apollo 16 mission was the second of what are called the J-class missions. And they were the scientific missions. They all had a rover, and they were basically intent to go to geologically or lunarlogically, whatever it would be, interesting sites. And but they were looking for add-on science things, and that's how that telescope got added. I actually remember that. I remember that was an interesting mission because they actually lost a good chunk of a day because of some problems on the lander after they'd undocked, and they couldn't descend, and they had to do a few extra orbits, which they figured out this issue, and then they managed to land it and deploy it. So they were actually shortened how long they could stay on the moon. But yeah, and I mean, we're going to talk a little bit more about going back to the moon, but the idea of putting a telescope on the moon is brilliant. One of the other ideas, is the idea of using craters and lining them with basically, because the shape is almost right. For radio astronomy, you could set that up, and it would be pretty cool. Just using a crater as your frame, and then building the appropriate dish and sensors, and it would be, if you did it on the far side, it would always be pointing away from the Earth, and that would be incredible.
Yeah, I mean, essentially that's what the original Arecibo was basically a telescope built into a little valley, right? And then it just had to be supported. Yeah. So you'd be taking, it's already been done on Earth. To do it on the moon would be, it's not even that technically that challenging, other than getting the stuff there.
Other than doing it on the moon, yeah.
Yeah, and the thing is, your whole framework and everything, I mean, the gravity isn't high, your framework and everything could be lighter. It would just be technically in some way simpler. Just getting it there.
Well, okay, so let's just do this as a thought experiment before we move on. Something like a plane wave 1 meter telescope is not so big and not so heavy, and it could be optimized. This is the same telescope we've got at the observatory. It could probably be optimized, put into a fairing, landed robotically on the moon on the far side, if you could find the right place. You can envisage what that would look like. You need to have some communication satellites in orbit around the moon to communicate with it, because it's not pointing to the Earth. But I mean, those are, and again, we're going to talk more about the moon and telescopes throughout this broadcast. But those are the sort of things that you could do. Not going to be easy, but it's not nearly as challenging as we used to think it was. And one of the things that changed our perception of all this happened on April 25th of 1990. So 36 years ago, it's hard to believe. But the Space Shuttle Discovery on that day deployed the Hubble Space Telescope. And honestly, astronomy was changed forever. Not just as a scientific instrument, and it had some issues as a scientific instrument initially, but it changed the public perception of astronomy. So the Hubble telescope, it's a big telescope. It's basically got a I think it's a 2.4 meter mirror, which is not huge, but it's more than twice the size of our observatory at York. So it's a big telescope, and it's got 5 instruments capable of observing in ultraviolet, visible, near infrared, those regions. So it covers a good chunk of the spectrum close to the optical, close to and including our optical range. It's outside of Earth's atmosphere, but it's still pretty close to Earth, so it's got some challenges because of that. And it has recorded some of the most amazing images. But interestingly, when they launched it, they'd never done this before. And they weren't really sure how to test the mirror properly. I think there were people who knew how to test it, but they weren't asked. And it was sent up with a mirror that wasn't right. And so the first images were not very good at all. Not nearly as good as they'd hoped for from a ground-based telescope. But Hubble had an advantage. It was serviceable. It was launched by the space shuttle, and it was designed to be recaptured by the space shuttle. And the instrument cluster was accessible, so they could get in there. Astronauts in spacesuits could get in there, pull out instruments, and replace them. And the initial thought was, hey, it'll be great to repair things. But the second thought was, as the mission goes on, we can swap out the instruments because we might be wanting to look at different things or because technology's improved, and all of that happened. And so the very first servicing mission was to put basically a pair of glasses on the darn thing. So it wasn't on the front of it like I'm wearing glasses in the front of my face. It was inside the optical path, so light's coming in from the telescope, from the star, and parallel light rays, or the object, hits the mirror, and they're concentrated because the mirror is concave, and into an instrument cluster. And in that instrument cluster, they put in some corrective optics. And this got the optics to exactly where they thought they should be. And they were able to start collecting images like you couldn't believe. And as a scientific instrument, it was unparalleled. We've now got other space telescopes that are more modern, a little better, although not quite visible light like this one is. James Webb is, for example, infrared telescope, and there have been X-ray telescopes and other things. But good heavens, what this thing has done for NASA's publicity, it has made the images are stunningly beautiful, depending on what's captured. And it also has taught us a fair bit about cosmology. For example, there was one point where they basically pointed Hubble. And one of the nice things about Hubble is you can point it very accurately for a long period of time at a particular region of the sky. And we're talking years if you want. You don't need to do it all in one shot, but you can capture a little bit of light from it now and a little light from it tomorrow night, and do that over a couple of years, and suddenly you've got a lot of data. And they pointed the deep field image at a blank part of the sky, part of the sky with nothing in it. And they found out it didn't have nothing in it. It was full of galaxies, and it really changed our view of cosmology in some ways. But Hubble's been going on for 36 years. In fact, looking at it right now, 36 years, 3 days, and counting. But it getting long in the tooth. It really is. I mean, the last servicing mission, the 5th servicing mission, was a while ago, and its gyroscopes are failing. Instruments are getting old. It is expected to decay into Earth's atmosphere in the 2030s. It is well past its best before date now, but there was this guy, Jared Isaacman, who proposed a mission to service it using the Dragon spacecraft, SpaceX's Dragon spacecraft, and a private mission. This guy, rich guy, and he sort of proposed to do it for NASA, and NASA said no. But fast forward a couple of years, and Jarek Isaacman, same guy, is now the head of NASA. So it wouldn't totally surprise me if the idea of that mission came up again. They'd have to do a few things. They'd have to replace all of the gyroscopes. They might want to replace some instruments for sure, and they'd probably want to boost it. But
a little bit higher up, yeah.
Yeah, I mean, I think it's running at about 400 kilometers now. It's running at 540 to 500 it's in quite a circular orbit. It's between 537 and 541 kilometers. And it goes around the Earth every 95 minutes. But, we run telescopes on Earth for a century. The Hale telescope is still going. So there's no reason you couldn't, the mirror won't decay much. So maybe it'd be great to see.
Maybe.
But it's just a remarkable instrument.
Yeah. It's just the only very sad thing right now is a lot of these kind of like keeping older missions going may very soon fall to budget cuts. And I think the sheer amount of work they might have to do on Hubble, when you've got James Webb and now the Roman telescope likely to go up, I mean, that might put a kibosh on any further like trying to extend Hubble much beyond the failure of all these things. The interesting thing I always found about Hubble is it was actually launched late. It was supposed to be launched a couple of years earlier. But of course, it was the Challenger disaster that happened, and so they had to put the project on hold. So it sat in a warehouse for a while, and I think this worried some people that there may have been some kind of decay to the instrument before they even launched it, because it sat ground bound for a much longer period of time than they thought it would. Hubble had a rough start all around.
It really did, but it's kind of the ugly duckling story. It started off as an ugly duckling and really turned into a beautiful swan. It's I've never really thought about this until I brought it up right now, but I wonder how many people developed their first love of astronomy based on a coffee table book of images from Hubble. And there were many coffee table books of Hubble images published.
Well, so the other thing, it came along right as the internet was getting going, so they could put all their images out to the public so easily by putting them on the Space Telescope website, right? They had their own whole website where they'd be publishing regular images. So this was the other thing from a timing perspective. It was just sort of just the right time, right? As the internet was really coming along, and it made it so easy to sort of put all this stuff out there almost right from the start. So that's the other kind of technology I think that made it so popular and so well known, is just that kind of point in time. So
yeah, it's right place, right time, I guess, and of course it was also because of the amount of data it's generated, it sort of foreshadowed not a problem that we have, but a reality we face with just the incredible amount of data we're now collecting and processing. And anyone who's listened to this podcast before with me talking about my favorite telescope down in Chile, which I won't mention today. Yeah, you mentioned it. Okay, Vera Rubin. Just the amount of data that's coming out of that, it's terabytes per night. Wow. So anyway, Mary Helen, I think you've also got another one for us, another history item.
You're kind of getting down to the end of our history, so I'll keep this one reasonably short. Speaking of interesting objects in the sky, of course, you have the supernova of 1006. And this one was fascinating because it happened around April of that year. So 1006 AD or CE or whatever I'm supposed to be calling it. And this is when they started to have like observations of, this is a first really good observation of a supernova that was observed in many places. It was seen in Europe. It was seen in the Middle East. We have good recordings in the Far East. And this one was recorded really well. It was probably an incredibly bright one as a supernova go. Like it would have appeared quite noticeably in the sky. Like this would have stood out. I don't think we've had a supernova in the last century or so that really sort of shows us like what do these things look like and get a picture of them. I mean, Hubble, yes, picked up pictures of supernovas and stuff, but this was a rather unusual event because supernovas happen fairly regularly, but they don't often become so naked eye visible that so many people saw it. So this was quite a spectacular event. I believe this is the one that later became the Crab Nebula that we all know. So, you know, that you've probably heard of. And of course, that has a pulsar at the center of it. So this was quite a fascinating object. And where this kind of became significant is people realizing, like tying the Crab Nebula back to these observations around sort of 1006 AD, which were happening sort of end of April, beginning of May of that year, and then tying it to modern astronomy, and modern astronomers now realizing there was value in going back into these really old records to find the returns of things like Halley's comets or supernova observations or regular observations of some nova that go off not quite that often, but like observably, and that these records actually had this value that I don't think they'd thought about as much before they really kind of caught on to this one. So it was kind of one of those interesting moments where they realized you could tie the historical records going quite far back to like events we're now studying now and objects we're studying now.
Yeah, I also thought it was the Crab Nebula, but it isn't. I just checked. It isn't. It's in Lupus, and it's SN 10,006 in Lupus. And just checking, because I thought it was the Crab Nebula. The Crab Nebula was a supernova in 1054, so 48 years.
I'm getting my dates a little confused.
Yeah. And if you go to the Wikipedia page, which is what I checked, SN 10006, there's a great, believe it or not, Hubble image
of course
of the nebula at the center. So there you go. And it was I guess it was a special type of supernova in the sense that it was likely two white dwarfs colliding that caused it. But yeah, so and then 1054, 48 years later, they had one that wasn't quite as bright, but it is Taurus A. Yeah. So like, there you go.
These it's like I said, but it's these kind of events in the historical record, these supernova, that sort of first twigged people to, oh my God, we can find more data historically by going back. And of course I mistake the two. I get the two confused. But interestingly enough, the observations were also taken around this time of year as well. Yes. So I can be forgiven a little.
Oh no, listen, as I said, I thought it was the same one. So it's a easy enough mistake to make. So we're at halftime, a little past it actually. So I'm going to move us along by putting out some reminders. You are listening to York Universe, the Space and Astronomy podcast from York University. We are broadcasting live from the Allan I. Carswell Observatory at York's Keele campus in Toronto, Ontario, Canada. Please look at our website, yorku.ca/science/observatory, to join in the chat. And if you have any questions or want to see, want to look at our content, please just head over to the YouTube channel and take a look. And don't be shy. We got some great people there who can answer your questions in the live chat. Tonight, you're listening to Professor Mary Helen Armour and me, Paul Mackin. I'd like to also take a moment to talk about our regular observatory tours. Our next tour is this Wednesday, but it's not a tour. It's our Arboretum visit, where you get to go up onto the fifth floor of one of the main parking lots at York. And up there, it's outdoors, and we've got a nice viewing area, and we have a bunch of telescopes, and you can get a chance to look live through our telescopes, as shown by some of our undergrad students usually, and maybe a graduate student or two will show up and show you their favorite objects and answer your questions. So absolutely worth doing, a lot of fun. We alternate on some sort of schedule, and it's really driven by the moon and phase of the moon and whatnot, between the Arboretum tours and the Observatory tour. The Observatory tour is where you can come and see our 60 centimeter and our 1 meter telescopes and see how they're used and how we do research with our scopes, and all the components of that. The tours are a lot of fun as well. To get a ticket, and we do ask you to get a ticket, although the tickets are free, just go to our website. You'll get your free ticket, and that allows us to plan, how many people are coming and whatnot. And these tours can get busy, so it's a good idea to book your time and show up. And it's a lot of fun. It's absolutely worth doing. Also, we've got our astronomy in residence applications open. So every summer up in Killarney, there's an observatory there, and York University provides an astronomer in residence for weeks at a time. It's try to cover the whole summer, and they will do public viewings and some solar viewings and star watching and whatnot. So this summer we might get some aurora, although we're past solar maximum, but there's still some sign of aurora happening. And we're, so you might get some aurora up there as well. If you're interested in applying, please do. Mary Helen, you've been an astronomer in residence, haven't you?
Yeah, I did it 3 years running.
Okay.
I always went up when the Perseids were fairly active, and I've seen some really good shooting stars because I was always up there on nights where the moon didn't rise until well after midnight. So we got some very good viewing in, and the dark skies over Killarney are incredible. I mean, even if you're not sort of an astronomer residence, if you're looking for a place to go camping, that is sort of great observing area. Killarney's a great park, and the lake is really great to swim in the summer. The one thing is it is dark skies, so there is no electric lighting anywhere in the park. So the camping, it's not like a commercial campground. There's no electricity, so you're kind of if you want to go, be aware of that. But it's a lovely place to go in the summer. I'm not going this summer because I have other things going on, but I've been the past 3 years, and it's been a great place to spend time. So.
Yeah, something I'd like to do again. I'm working in one of the other labs at York University for the summer, so I won't be applying this year, but I might think about applying for next year. So, but anyway, so back to our other items. It's time for some news and discussion. So, Mary Helen, you've got something on Mars, boring orangish ball. Yes.
Yeah, well, and this is where the ball isn't so orange. What's interesting is they have compared some of the pictures in the 1970s that Viking took in a region called Utopia Planitia, which is sort of at the northern end and a little east of where the Big Elysium volcano field is. And what's interesting is there seems to be there was dark material spread on the surface over a certain area. And what's interesting from the time of the Viking images, when they now compare them to the Mars Express, it seems like this dark material is sort of moving across the surface. They don't exactly know why. And it's very interesting because, of course, we don't think of Mars as being very active. And yet, over time, we can see these clear surface changes. And it's a real interesting question. Is this some sort of wind activity where it's been blown? Is there something else going on? This kind of stuff is kind of neat. And if you go to the European Space Agency webpage, and you just type in ash creeps across Mars, they have one of these really cool pictures where you can kind of move the slider back and forth and see the before picture that Viking took, and then sort of the after picture that Mars Express took. And it's quite distinctive. Like, this isn't sort of a subtle difference. This is some sort of really dark, what they think is volcanic ash, quite heavy, dark stuff that seems to be creeping across the surface. And it's kind of cool to see that, yes, Mars does actually change over time. We don't think about it, but clearly things are going on the surface, and what is causing this ash to move. So it's really kind of an interesting area. There's a lot of other geology in this area, fractures, craters, that kind of thing. But those haven't really changed from the Viking image to this one. And yet you have this dark volcanic ash moving across the surface, and quite noticeably, not like a short distance. You're talking hundreds of meters, if not kilometers, that it has moved over time. So it's quite a noticeable change, and just in the space of a few decades, which is geologically is really fast. For Mars is quite significant. This wasn't really something they were expecting until they started comparing like the older images with the newer ones.
I find Mars fascinating. I really do. And when I talk about it being dull and boring, it's because it's a relatively small planet. I like astrophotography and a lot of observational astronomy, but it's a small planet. Doesn't show great in a telescope, but when you get there with a spacecraft, good heaven, it is a geologic. It's for someone who's a geophysicist, I think it would be a fascinating place.
It's a geologist's dream, because there's no water, there's no plants, there's nothing in the way. There's just straight out geology.
Yeah,
I mean, that's the geologist's nightmare on Earth. It's like there's so much vegetation and all this stuff in the way. You get to Mars and God is, oh, this is beautiful. Yeah. So it's kind of that way. Geologists get, and it's so visible, and there's so much good imagery. I mean, Venus clearly has geology too, but it's covered in clouds. Mercury is very hard to observe because it's so far away. So Mars is this little geological gem.
Yeah, it is. And the good news is
planetary sciences. Yeah.
And the good news is we've got good instruments there, and more coming. Coming. And we're going to allude to that a little bit in one of our segments as well. But Mars is anything but boring. It's just boring through a telescope.
Yeah.
But once you get into orbit and get on the surface, it's a happy place.
Oh yeah.
But also in space, we talked about the Hubble Space Telescope. Kind of successor to the Hubble Space Telescope, the Nancy Grace Roman Telescope is launching this September under budget and ahead of schedule, about 6 months ahead of schedule, and it is under budget on a Falcon Heavy. It's going up on a Falcon Heavy, which is a very impressive spacecraft in its own right. But the Nancy Grace telescope is a really interesting telescope. It's kind of an afterthought. What happened was that it's the same size mirror as the Hubble Space Telescope, the HST, and it was developed by the Department of Defense, and it was designed not to look into space, but to look down at Earth from orbit as a spy satellite. And that meant that its optics were designed in a very particular way. It's something that we astronomers and photographers call very fast, meaning that it takes a lot of light and concentrates it over a very short distance. The curve in the mirror is quite steep compared to something else like HST. But this means that it's got quite a wide field of view. It can collect a lot of light, concentrate it into a small area. So It's about the same size, 2.4 meters. It's got it's got two different instruments, so it's not quite as versatile in terms of its instrument cluster as HST, but it's got a wide field instrument, which has got a 300 megapixel camera, far better than anything on Hubble. And it's designed to work in visible and infrared light, okay, which is really going to be great because the James Webb is a is an infrared instrument. This is a little closer to the visible light end of the spectrum, but it's going to be very good for a few things that we'll talk about. It's got a second instrument, which I'm really fascinated by, the Roman coronagraph, which is kind of an eclipse maker. You point the coronagraph at a star far away, but it's designed to block the light. You wouldn't use this on our sun, to block the light from that star, which sounds counterintuitive. You're going to look at a star and then block the light from it. But the idea is, if you do this just right, you block out the glare of the light from the star, and you're able to take a look at planets around the star. And this has been tried a little bit, but this is the first time we're really ever deploying one as a production instrument per se. So, it will actually reduce the light that's taken in from distant stars, but such a way that it reveals planets orbiting them. The system will actively adjust itself to the light of whatever star it's looking for, and it's the first real system to ever do this in space. The Webb's taken some great pictures, and we've got Hubble but Roman is more of an explorer as well. It's scanning across the sky at a high level of detail, and it will discover entirely new things. It's going to be looking for new galaxies, and possibly billions of new galaxies. It also is going to be able to look at a few other things, maybe asteroids and whatnot, because you're going to have some relatively cold, dark objects out there that might show up in infrared. This telescope is like Webb. It is not going into Earth orbit. Not really. It's going up to what's called an L2 point, Lagrange 2 point, which is a distant spot. It's quite far away, in kind of 1,000,000 kilometers away, and it's on the other side of Earth from the sun, and that's a gravitationally stable place, so it can basically stay there without a lot of fuel. Keep pointing away, and it's blocking out the sun quite nicely, just the way it's pointed, and so it won't be serviceable per se, but it will begin its mission. It's going to get out there. It'll take a while to get out there, a couple of weeks to get out there once it gets launched in September. And we should be seeing some great results from it, I would think, early next year.
Yeah, it's kind of a fascinating mission. I mean, it's one of these things where they're trying to be more budget conscious and efficient, and I think it's really done a good job like that, because space exploration is expensive, and it can be quite risky. So sometimes I think having some of these less expensive missions or repurposing makes a lot of sense, just because of the sheer cost involved. And it's like I said, with the current situation NASA is in, with having their budget and slashed everything, just being able to do things under budget is probably quite kudos to them and makes look good on them. So it's like I said, it's a bit of a different approach than Hubble, but putting it out in the stable Lagrange point does have a lot of observing advantages, because you don't have the issue of passing in front of it, like orbiting this Earth every 90 minutes. You're whipping by the sun less than an hour apart. Sunrise and sunset sunrise and sun followed by sunset in 45 minutes does affect your observing ability. So this might be a totally different kind of observational experience, and hopefully the launch and everything goes smoothly. So,
and it's interesting, and we'll get to this in a little bit. This is a telescope that was canceled a couple of times, even though NASA got the mirror for free and so on. But basically because of budget issues. But Congress, and we'll talk about the administration versus U.S. Congress battle on budget in a minute. But it was revived by Congress, and it is going to be, I mean, we're getting some great instruments. I mean, the data capture end of astronomy is going through the roof. I mean, you've got Vera Rubin, you've got all the large telescopes out there. The European Very Large Observatory is coming online. Good Lord, there's just so much out there, and Nancy Roman is just going to be a remarkable add-on to the plethora of tools astronomers have. It's amazing.
Yeah.
But Mary Helen, you've got something on a comet.
One quick idea about repurposing, and I don't think this was necessarily something they thought that hard about. But the SOHO, the Solar Observatory, that has been out there for quite some time now, has a very interesting sort of secondary career as a comet hunter and taking images of comets. And of course, there was a comet called Pan-STARRS that just went around the sun and came back out. And in the last couple of days, sort of passed, hit its sort of closest approach to Earth. And it's very interesting because it wasn't really that visible from Earth, despite being its closest approach. But SOHO got some, the Solar Observatory got some really good images of it as it sort of passed the sun. And the really cool thing they saw is as it sort of gets to the end of the observational, right as it's sort of, starting to go out of the field, it suddenly develops a tail. So it's quite interesting because you see this image and you can see it quite distinctly in the SOHO image. And they have some lovely little videos of it. If you just kind of like search Pan-STARRS comet, April 2026, there'll be a whole bunch of stuff that comes up, but they have some really lovely sort of movies of it sort of passing along through SOHO's field of vision. And right as it gets to the end, it starts to develop this tail. They thought Pan-STARRS might become naked eye visible. It hasn't. It was visible in the fall through telescopes and stuff. And now it's sort of heading back out again. But it goes to this idea, I think, of repurposing. And SOHO was meant to be a solar observer, and yet it's observed an awful lot of comets over its time, which I kind of found fascinating. And there's this little video where you just kind of catch it, and all of a sudden at the end, this tail develops. And the thing you have to remember about the tail of a comet, they always point away from the sun. Because they're related to material being blown away by the solar wind. Some of them can curve a little, but they always sort of point in the direction away from the sun. So all of a sudden you see at the end this little sort of, spike come out of the comet sort of heading out of the picture. And it's really quite a fascinating little video to watch.
So. Yeah, it's amazing. It's, again, space instruments and sometimes they capture things that you don't expect, and my favorite story of sort of unexpected side effects from SOHO's a great one, but there's also other instruments that were intended to do one thing and ended up being repurposed into gathering other data, and so is a great example of that. And we have a tendency to overbuild these things, which means they last a lot longer than you expect, and you can have primary missions and secondary missions. SOHO's been there forever. Like, it's a really old piece of technology. You talk about Hubble as well. It's well past its lifespan. And if we extend it, yes, it's going to impact budget, but is that worth it? You've got this instrument out there. Is it worth keeping going? We've been keeping the Voyager probes going, and there's, intentions to keep them going even longer, even though they're almost too low on energy to work anymore. But this brings up the subject of budgets. And this is, I find this a frustrating story. Very predictable. The current administration in the U.S. has, for the second year in a row, significantly cut NASA's science budget, and this is a problem. I mean, we're talking about overall a 30% reduction in the science in the budget, which translates to about a 60% reduction in the science budget. Um, Now, last year it didn't happen. They proposed it, but the administration in the U.S. does not control how money's allocated. Congress does that, and NASA is very popular with the public and with Congress, and in states where there are NASA centers. Uh, so what happened last year was that NASA proposed, the White House proposed this budget, basically the same one as this year, and Congress said nope, and they restored pretty much full funding. Uh, and so we've got the same situation happening again. And already one U.S. senator who's from Texas, which is a big NASA place, has turned around and said to NASA, "Don't worry, we're not going to. Congress is not going to let this happen. You guys focus on your science and your space missions, and we'll focus on getting you the money to do it." And it's quite dysfunctional, and it makes it difficult to plan. But I guess it's the dance that is happening right now. Interestingly, though, this this is the same time, after several weeks after Artemis 3 was not only successful, and that's fantastic news. It was successful, but it was also breathtaking. I'm old enough to remember as a child the lunar landings. I remember Apollo 8. I remember Apollo 10, which happened, in 1969 this week. But it was wonderful for me to see my younger colleagues experiencing the wonder I felt as a kid by going back to the moon. Now, the mission, wasn't as impressive as some of the NASA missions, landing and whatnot, but it was very impressive nonetheless. And it will get more impressive as the other missions. So you've got this weird, we're going to cut the budget. We're going to cut the budget. We're going to cut the budget. Oh, and by the way, we're going to the moon in 2028. We're going to land.
How
but we're cutting the budget.
Pay for this?
yeah. But we're cutting the budget. But we're going to the moon. And of course, they nominally do this by cutting the science budget, which is a lot of the missions we've been talking about here today. But again, I think last year there was so much public outcry and so much congressional outcry, they recovered the budget, and I believe cooler heads will prevail. But it's very difficult to plan, and of course, going to the moon requires a huge amount of upfront planning. And I mean, it's not just budget concerns that are confusing. The missions, the next Artemis 3 mission is designed to send Artemis, has been revised, to send Orion into Earth orbit to dock with one or both of the proposed landers, one by Blue Origin and one by SpaceX, neither of which exist yet. And it's a year away. And they're talking early next year. So it's very confusing. And to add insult to injury, Blue Origin launched their New Glenn rocket for the third time last week, and it launched beautifully. And the first stage turned around and landed on the drone ship exactly as expected. But the second stage failed, and it failed to put the satellite that it was launching into the correct orbit. So clearly, there's still some work to be done. And of course, the lander for SpaceX is based on Starship, which has yet to go into orbit. And now these are complicated systems. I'm not slamming SpaceX. I'm certainly not slamming Blue Origin either. These are complicated things. But again, this requires planning. It requires a dependable timeline. And unfortunately, Nancy Grace Roman going early and under budget is not typical.
Oh God,
so
no.
there's a fair bit of confusion right now in terms of Artemis, and I will say that it looks like there's a steady hand at NASA with Jerry Isaacman, who does know his stuff. I mean, he's an astronaut, and a private astronaut, but an astronaut nonetheless. He's a real enthusiast for space. So they'll get there. Just don't expect Artemis 3 to be on schedule right now, I would say.
I'm guessing it will not happen under the current administration. It's just going to take, like, you're at least, if you haven't even got the Leonard capsule, you're at least 2 or 3 years away. So
yeah, I think my guess is that the way things stand now, there is a very good chance that China will get to the moon before the US does. I think they've got a clear plan, and it's well funded, and they've got a schedule. And I mean, we're Canadian, so we've got skin in the game. We had an astronaut on the last mission. The Canadian Space Agency is aligned with NASA for sure. But I'd have to say that my gut tells me China will get there first.
Yeah. Oh, yeah. The scientific dysfunction in the States is so bad right now. I can't see them getting there before like 2028, I think would be really optimistic. It's probably now you're pushing it out like 4 to 5 years at the rate they're going.
Yeah. I would guess the way they're going right now, you might see 2030, 2031. Yeah. And they've got to get a lander.
Unless the Chinese start really look like they're going to get there and you ignite another space race and the US realizes we got to stop messing around.
Yeah, I think so. Well, friends, it's time for us to close up our podcast for this evening. And I want to thank you for joining us. You've been listening to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Professor Mary Helen Armour and me, Paul Mackin. The podcast and past episodes are available wherever podcasts are distributed. You can always connect with us on Instagram at York U Observatory or on Facebook at Allan I Carswell Obs. Our website is yorku.ca/science/observatory, and there we have a lot of interesting content. And if you feel so inclined, it's a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. Thank you for tuning in this evening. We wish you clear skies, and the time of clear skies is now definitely showing up. And a good evening. Have a great spring, and we're looking forward to summer, everyone.
All right. Bye.
Bye.